Fourth grade lesson 6.2 is generating equivalent fractions. So we learned what equivalent fractions were, and now we're going to learn how to use that knowledge to our advantage. So the essential question is, how can you use multiplication to find equivalent fractions? And we'll do the unlock the problem. Sarah needs 3/4 cup. You can also pronounce this as 3/4. We know that there's 4 quarters in a dollar, right? So 3/4 or 3/4 cup of dish soap to make homemade bubble solution. Her measuring cup is divided into eighths, into 8 as a denominator. What fraction of the measuring cup should Sarah fill with the dish soap? So you may have run into a problem like this if you cook a lot. You might need a certain measurement in cups or teaspoons or whatever. Well, let's say cups, in a certain measurement in cups of something, but you don't have that size cup. And so you have to figure out what you can use instead and how much of it. So we're going to go through this, unlock the problem, and see how to solve this issue. Is an eighth size part of a measuring cup bigger or smaller than a fourth size? And this is where things get tricky with fractions and their denominators, because our brains all think of certain things as bigger or smaller. Let's look at what an eighth is and what a fourth is and help our brain make a connection. Okay, so first of all, an eighth size means an meaning one, right? We're singular. 1/8 size. An eighth is our denominator. So 1 out of 8 is an eighth. And 1/4, the fourth size part, 1 out of 4. If we take a look at the measuring cup, let's say this is 1 full cup, and we split it into 4 equal pieces, 1, 2, 3, 4. One of those 4 pieces is this much. If we take that same size measuring cup and we split it into 8 equal pieces, 1/8 is that much. And you can see that that is less than this, right? What our brains have to work around is that in our brains, we think 8 is a larger number than 4. And we want to say it's the bigger amount. But when it comes to fractions, think of this denominator, this bottom number, as how many people you have to share with. If you have a candy bar and you have to share with 4 people, or you have to share with 8 people, which is the scenario that you get more candy bar? You get more candy bar if you're sharing with 4 people than you do with 8 people. So if you tell your brain that this denominator is reflecting how many people you have to share things with, it helps your brain recognize that the more people you have to share with, the smaller your portion gets. And that might help you determine that, recognize, and as you go along, recognize that large denominators mean small, tiny, tiny bits. So the eighth size, the 1/8 size, is smaller than the fourth size. So we're going to put smaller here. And they say, find how many eighths are in 3/4. Okay, so now we're going to compare the 3/4 to the 1/8, or how many eighths it will take. How many 1/8 will it take? Okay, so we're going to shade, we have this cup again, and there's 4 equal pieces. We're going to shade in 3 out of those 4 now, because that is the amount they're asking us about. So we're going to go 1, 2, 3/4. And now we have an eighth size parts. 1, 2, 3, 4, 5, 6, 7, 8 size parts. How many does it take to equal that, to make them equivalent? And so I'm going to draw that line across there just so you could see where that equivalency looks like. And so it takes me 1, 2, 3, 4, 5, 6 eighths. 6 eighths is equivalent to 3/4. Now let's recall, I'll write it down here, 3/4 is equivalent to 6 eighths. Let's recall from the last lesson that whatever we multiplied our numerator by to get that, we would have to do the same to the denominator. So let's see if this is true. It takes 3 multiplied by 2 in order to get 6. And is 4 multiplied by 2 8? Yes, it is. So these are in fact equivalent. And now that I'm looking at this, I think I got a little out of order here, or ahead of myself. I did the question to this over here, And then I did the question to this down right here. So as long as it makes sense to you, hopefully it makes sense to you. They shade the model of 3/4. Here they just wanted 1/4 and 2/8, so you can compare them. And here they want 3/4, like we did here, and the eighths in comparison, the 6/8 as it turned out here. So we did this part for this and this part for that. Hopefully that makes sense. If it's, don't worry if it's different on your page. I'm not worried about that. I'm just worried that you understand the difference between the two. So we would need 6 8 size parts to make 3/4 size parts is what we found out. 6 8 size parts to make 3/4 size parts. So Sarah should fill 6/8 of the measuring cup with dish soap. So they want us to explain why 6 8 size parts is the same as 3/4 size parts. And we can explain that however you wish. We can maybe say that the denominator was doubled, so the numerator had to be doubled too, or it takes 2/8 to make 1/4, so we needed to make that adjustment. You decide how do you want to word that, but we just needed to double things. We had fourths, we had eighths, and we needed to make fourths, and it took two of those to make one of those. So this next example wants us to write 4 fractions that are equivalent to 1/2, or 1 out of 2 parts. 1 out of 2 parts is always referred to as 1/2. So here is 1 out of 2 parts, 1/2. And they modeled equivalent to that is out of 4 parts, 2/4. 1/2 is the same or equivalent to or equal to 2/4. This amount of pizza is the same amount as these 2 pieces put together. And we see that we did 1 times 2 equals 2 and 2 times 2 equals 4. We multiplied both our numerator and denominator by the same number in order to keep the fraction equivalent. Let's take a look at the next one. 1/2, and now they have split it into 1, 2, 3, 4, 5, 6 equal pieces. That is a denominator of 6. And we can see that this equal amount took 1, 2, 3 of the 6 to make that equivalent. There's our visual for that. We did 2 times 3 to get 6, so we need to multiply our numerator also by 3 to keep it equivalent, and 1 times 3 is 3. So they're giving us the visual and then the mathematical way of doing that. All right, 1/2, again, 1 out of 2. Now it is split into 1, 2, 3, 4, 5, 6, 7, 8 pieces. 8 pieces. And out of those 8 pieces, 1, 2, 3, 4 of them are the equivalent part. 4 out of 8. Well, what did I multiply 2 by in order to get to 8? I multiply by 4, right? So 2 times 4 equals 8. And whatever I multiply my denominator by, I have to multiply my numerator by in order to keep it equivalent. 1 times 4 is 4. And finally, we have the comparison of 1/2 to this amount. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces, 10 total as our denominator. And out of those 10 pieces, 1, 2, 3, 4, 5 are shaded. Well, if I'm doing this mathematically, what do I multiply 2 by in order to get 10? 2 times 5 is 10. And if I'm looking for equivalent fractions, then whatever I multiply my denominator by, I have to multiply my numerator by. So we'll do 1 times 5, which is 5. And of course, this is in fact 5 out of 10, 5/10. So equivalent fractions to 1/2 could be 2/4. It can be 3/6. Here's the image there. It can be 4/8. 1, 2, 3, 4 out of 8, 4/8. It also can be cut up and in 5/10. 5/10. So let's look at the bottom of that page. It says, look at the model that shows 1/2 is equivalent or is equal to 3/6. This one here. How does the number of parts in the whole affect the number of parts that are shaded? So I'll write it bigger here. We have 1 shaded out of 2 total on this one. And then we had 3 shaded out of 6 total on this one. And how much did it increase by? It tripled. It went up by a multiple of 3, right? So what we can say is it is 3 times more on both meaning the numerator and the denominator. It's 3 times the numerator and 3 times the denominator. Or it is triple the numerator and triple the denominator. Explain how you can use multiplication to write a fraction that is equivalent to 3/5. Okay, knowing that whatever we keep fractions equivalent no matter what, as long as we're fair, as long as we multiply the numerator times the same number as we do the denominator. As long as we do that, it will always be equivalent. We're taking that very, very same amount and we're just chopping it up into different pieces. But we're not changing the amount. It's still there. We're just cutting it up differently. So if we had 3/5, we can multiply the numerator and denominator by any number. As long as we did the same to both the numerator and the denominator, it would still be equivalent. Doesn't matter. We can multiply them by 10 if we want to. And we would get 30/50. 30/50 is the same amount as 3/5. It's just that this person who's getting 3 pieces of pie out of the 5 pieces that are there are getting 3 big pieces. And this person that's getting 30 pieces of pie sounds like they're getting so much more, but that pie is cut into 50 itty bitty pieces. So they're getting 30 itty bitty pieces that becomes equivalent to that. And the final question, are 2/3 and 6/8 equivalent? Let's see. Well, what am I multiplying 2 times and able to get a 6 with? And I might sometimes start with a 3. What do I do 3 times and get an 8? And I know my multiplication facts. By now, I know you guys have been working on the multiplication facts. You can see why I've been pushing it so hard. 3 times nothing really gives me 8. Nothing is a whole number anyway. So I'm going to jump up to this one instead. 2 times what gives me 6? Oh, 2 times 3 gives me 6. So what I'm doing here is tripling this or multiplying by 3. So in order for this to be equivalent, then I would have to be able to multiply my denominator times 3 as well and get 9, but I didn't. I got 8. No, no, no. So as soon as I see that happen, I can say, no, they're not equivalent. How can I explain? I guess I can put down that the equivalent would be 6/9. I can put what the correct one would be. 6/9 would be equivalent. All right, so let's look at the Sharon show. We have 1, 2 out of 1, 2, 3, 2/3, 2 out of 3. And then we have 1, 2, 3, 4 out of 1, 2, 3, 4, 5, 6. Are they equivalent? Well, looking at the image, we can see that they are. So here they are written. 2/3 is equivalent to 4/6. Let's put we have 2/3 was multiplied by what multiplier to get to 4/6? Let's put the 4/6 here. Well, 2 times what number gives me 4? 2 times 2 does. And if this is in fact equivalent, then 3 times 2 will be 6, and it is. As long as you multiply the numerator by the same number as the denominator, it will be equivalent. Let's take a look at the visual. We have 1, 2, 3, 4, 5. We have fifths. 1, 2, 3 of them shaded, 3/5. And over here we have 5, 10 total with 6 of them shaded. You can see visually these look equivalent. 3 times what number gives me that 6 for 6/10? 3 times 2 does. And if this is in fact equivalent, then 5 times 2, we have to use the same multiplier, will also give me 10. And it does. 5 times 2 is in fact 10. So these are equivalent. As long as I multiply the numerator and the denominator times the same number, is staying equivalent. I have 1, 2, 3 denominator with 1 shaded, 1 out of 3 shaded. I have 4, 8, 12 denominator with 4 shaded. This looks like the same amount visually. Let's put 4/12 over here. Check the math. 1 times 4 equals 4. And so if 3 times 4 equals 12, then I'm equivalent, and it does. Okay, now let's go in reverse. Let's use it the opposite way now without the visual. It doesn't matter what number we choose here. We're going to have all kinds of different answers. People will have all kinds of different answers here, but they'll all be correct as long as you're using the rule that the same number is multiplied by numerator and denominator. So we want equivalent fractions. They want 2 equivalent fractions. Doesn't matter what they are as long as you're following the rules. So the first one I'll do for 4/5 is I'm going to do the 4/5 times, I get to choose a multiplier. I'm going to choose 2. That's an easy one. 2. As long as I do the same to the numerator as denominator, it will be equivalent. 4 times 2 is 8, and 5 times 2 is 10. So 8/10 is an equivalent fraction. Also, they wanted 2 of them, right? So let's do another one. Let's multiply it by 10, because multiplying by 10 is so easy. 4 times 10 is 40. 5 times 10 is 50. That's an equivalent fraction to 4/5 because I multiplied the numerator and denominator by the same number. So some equivalent fractions to 4/5 are 8/10 and 40/50, among many others. 4/5 and 40/50. Let's take a look at number 3. They want 2 equivalent fractions for 2/4. So I start with 2/4 and I choose what I'm going to multiply it by. Let's do times 3 this time. Let's do times 3, challenge ourselves with our 3's. Same to the numerator as the denominator. 2 times 3 is 6. And 4 times 3 is 12. So 2/4 is equivalent to 6/12. All right, let's do another one. 2 times, let's do 5. 2 times 5 is 10. And we're going to do the same to the denominator. 4 times 5 is 20. And so 10/20 is equivalent to 2/4. So 2/4 is equivalent to 6/12. And those are also equivalent to 10/20. I could have done 2/4 times, I'll do it like this, 1,000,000 if I really wanted to get big on this. As long as I did the same to the numerator as I did to the denominator, it would stay equivalent. 2,000,000 over 4,000,000 is equivalent to those two. So that's the whole thing on this. Play with that a little bit. You make those connections and you'll be good.